All right, here we go. It's called the rational root theorem. I'm not going to give you some big, long, crazy definition they do in the book. I'll tell you what, I have a hard time understanding what they're writing. I can't imagine kids understanding. No, you weren't. No, you weren't. You slapped him on purpose. I saw it. Okay, I know exactly what you're doing. What do you think? I'm 100 years old and I don't know what you're doing? Okay, they've been doing that since the dark ages when I was in school. Okay? All right, so here we go. I'm just going to do the example and kind of teach you this rational root theorem through the example. I think that's the best way to do it. So here we go. It's going to look very similar to what we've been doing, especially the first one. The first one's really not much different. Let's see, where is it? Oh, there it is. Oh yeah, the first one is different. Okay, good. So here's example 1. It's going to say list all the possible rational roots. Okay, it's in your book. I'm not going to write all that stuff down. I'm just going to write down what your equation is. Two. All right. And then it says determine the rational roots. I'm going to write that down because that sounds weird. It's like, what in the world are they asking me to do? They're just asking to find the answer. It's all they're asking you to do. All right? Determine the rational roots. Which means they're not looking for any irrational roots, okay, or any imaginary numbers, that kind of thing. Just the rational roots, okay? Anything that you could write as a fraction is what they're asking for. All right, here's what we're going to do. There's this thing P and Q. P is represented by the constant, all right? So P is the constant. We're going to use this, all right? And then the Q is represented by this number. Use the arrows, use the arrow again. All right, by this is the leading coefficient. All right, so that's the Q, leading coefficient. I'll just shorten it like that. Okay, everybody with me? So what we're going to do is we want to find the list of possible factors. Remember on that last problem, the constant was a 1. So what were our possible factors? It was +1, -1. Do you remember that? It's very, very similar to that with one little twist. If you have a number that's not a 1 right there, okay, you're going to have to do something a little extra. And the little extra is this rational root theorem, all right, which says that the possible values, the possible factors, actually I wrote down roots. The possible roots are this. The possible roots, okay, of my polynomial is P over Q, all right? So P over Q are my possible roots. Remember, what we used to do, okay, just on that last example, okay, or that last homework, we just took this. So what if this was a 1 right here? What are the possible roots that we've already done before? It's not a new thing. What are my possible roots for if this was a 1 right there? It would just be plus or minus what? 1 plus or minus 2. But this is a little bit different. All right? You can still put that in here. All right? The P is the constant. So what are my possible roots of the P value, the constant value? Yep, plus or minus 1, and I'm just going to put a comma 2. This means that everything after it's still plus or minus. Is that all right? So I don't have to write plus or minus a million times. What about the Q? What is the Q? The Q is the 6. So the P is the -2 or the 2. It doesn't really matter because you're going to go plus or minus anyway. All right? And then what is the Q? It's the 6. So let's write all the possible values or all the possible factors of 6. Well, 1 and 2. What else? 3 and 6. Agree with that? All right. So now, here's what's different than what we did before. And if you have a number out in front of this, if you have that leading coefficient other than 1, this is what's going to happen. We have a lot more possible roots. We don't just have plus or minus 1 and plus or minus 2. We have this. This is the division. So let's write down all the possible values. So we got plus or minus 1 over what? 1, okay, which is 1, all right? And then 1, I'll tell you what. I mean, you could go 1 over everything, then 2 over everything, but I think what I did is I went, what did I do? Yeah, I did this. I did the 1, and then I did the 2, all right? I'll show you why. It doesn't matter. It really doesn't matter. Let's just do the 2. So 2 over 1 is what? Plus or minus 2, all right? So we got those out of the way. But now let's do the actual fraction part. I mean, those were fractions because it was 2 over 1. But let's go back to the 1. And yeah, let's go back to the 1. So what I got? I got 1 over 1. Then I got what? 1 over 2. So that's going to be included. So plus or minus, I'll write it in here, plus or minus 1 over 2. Then what else? 1 over 3. And then 1 over what? 6. Okay, so I did all the 1 over top of these. Now let's do the 2's over top of these. I already did the 2 over 1. I put it right there, okay? Let's do the rest. So I went 2 over 1. What about 2 over 2? What's that? It's a 1. But I already got a 1 here, don't I? So I don't have to worry about that. This is what? 2 over 3, right? Plus or minus 2 over 3. And then what else? 2 over 6, which is 1/3. I already got a 1/3, so I don't have to worry about that. So those are all my possible roots for this polynomial, for this equation right here. All right? So now, look, you got a lot of choices. But luckily, in a high school math class, they don't make you choose a ton of those. All right? So what I like to do is I like to put the whole numbers first. All right? Go from the smallest one to the biggest one, and then put the fractions after that. That's why I did it in that order.
If it's 2 over 2, we're going to
Yeah, that's why I didn't write it. That's why I didn't write it 2 over 2. See, 2 over 2 is a 1. I said, when I wrote this down, I said, I already got a 1, so I don't have to do it again, right? I got the 1 from 1 over 1, but 2 over 2, yeah, is a 1, but I don't have to rewrite it.
So how do we get 2? That's from the 2.
From the 2 over 1. From the 2 over 1. See that? So I went 1 over 1, 1 over 2, 1 over 3, 1 over 6. Then I went 2 over 1, 2 over 2, 2 over 3, 2 over 6. Some of them repeated, so I didn't have to repeat them. I just kept them. We good? All right, so now, what are we going to do with these numbers? Well, you're going to take this 6x cubed plus 11x squared minus 3x minus 2, and what are you going to do to them? You're going to go f of what? Yeah, just try them, okay? Just keep trying them until you see what works. So let's try a 1. Sometimes you can just do this in your head. If you can, that's great. Just move on to the next one. They do suggest in the book, which I don't know if I like because I don't want you using your calculator unless you really have to. But they suggest graphing it, all right? So like if you graphed it, right, and you go on Desmos and you graph it, and I don't know, it looks, actually, yeah. Now it would look like, what would it look like? Would it look like that? 1, 2, 3. Yeah. Okay. It would look something like this. Okay, that's super general, but that's kind of what it would look like. So they suggest in the book that you use Desmos, and then what are your possible x values? What are your possible roots? It'd be right here, it'd be right here, and it'd be right here. Okay? So they're like, oh, just use that point, right? And use that point, and use those would be factors. So that would be okay. But I don't want you using your calculator on this. All right? So I'm not going to have you do that. So we're going to have to do it the old-fashioned way, just plug stuff in and see which ones work. So far, I have not seen where you had to plug a ton in. This is probably the example, the one problem that you have to do more of plugging in and it doesn't work until you find something that does work. Does that make sense? It's kind of weird. But let's just plug it in. Let's see what we get. Put a 1 in for this. I don't know. Can you do this in your head? You have to write everything down. Let's do it. 1 here, that's a 1 times 6 is what? 6 plus, that's a 1, that's an 11, minus what? 3 minus 2. Is that going to give you 0? 17 minus 5? No. I don't even care what the number actually is. All I care is that it's what? It's not 0. So I'm not going to use that. So what's the next thing you might want to try? Yeah, I would try -1 before you go to 2. Now you could go to 2, right? You might get lucky and get it right. But I would just go in order. All right, so let's try f of -1. I don't know, can you do this in your head? -1 cubed is -1 times 6 is what? -6. -1 right here is positive, so it's a plus 11. -1 right here makes this plus 3, then minus 2. Is that going to give you 0? Nope. That's a 5. That's a 1. Nope. Doesn't give you 0. So that doesn't give you 0. Keep trying. Yeah, I would go to a 2. I mean, you could try these fractions if you wanted to. Do you really want to put a fraction into this and cube it and square it and then add them all up? No. But you may have to, depending on the problem. But I would not do that at first. Okay, I would try the whole numbers first. Hopefully, we'll get one of those integer numbers to actually work. So let's try a 2. Now, I will have to write this down probably. I don't know, maybe not. 2 cubed, what's that? What's 2 cubed? It's 8 times 6 is 48, right? 6 eighths are 48. All right, put a 2 in for this. 2 squared is 4, plus 11 is plus 44. Agreed? Put a 2 in for this. Minus 6, then minus 2. Is there any way if I add those up and I just take away 12, that's going to be a 0? No. So it's not 0. All right? Hopefully it is. So we keep trying. All right? Let's put a -2 in for this. -2 cubed is -8 times 6 is -48. Put a -2 in for this. That's a 4. No. It's -2 squared, which is positive 4, right? Times 11 is positive 44. Okay, you're just putting a 2 in for this. And then put a -2 in for this. -3 times -2 is 6. And then minus 2. Let's see what that comes out to be. That's -4. That's a positive 4. Sure enough, it does come out to 0, doesn't it? And that's what we're trying to find. So it wasn't that bad, was it? You tried a few numbers. You can do a little bit in your head. It shouldn't be all that bad. But we finally found it. Luckily, we didn't have to put any fractions in there. But these are possible. Remember, these are possible roots. Are they all roots? No. They just have a possibility of being a root. So one of these, or if not more, are the roots to this polynomial right here. We found one of them, which is nice. It's f of -2. So guess what I'm going to do? Take that -2, and I'm going to divide it into this stuff right here. So I'm going to take this and divide it by x. It's technically x plus 2, isn't it? That would be my factor. So my factor would be x plus 2. So that's one of my factors right there. I'll circle it. But how do I find the other ones? I take that -2, and I take this and divide it by that -2. So I go 6, 11, -3, -2. Little synthetic division. Are you getting good at synthetic division now? Hope so. If you did the homework right, you should have done it a bunch of times. Bring down the 6, multiply, -12, add them up, -1. Multiply, +2, add them up, -1. Multiply, +2, add them up, 0. If this does not come out to 0, you did something wrong. We said that earlier. All right, so make sure that that comes out to a 0. Or you didn't pick the right factor, or you just did your division wrong. Okay, could be one or the other. All right, so what is this? That's our remainder, that's our constant, that's our x squared. So I've got 6x squared minus x minus 1, right? And this is being multiplied by x plus 2. Remember, that's my factor, and that's my factor. Are we finished? What do you think? Probably not. You probably could factor this, okay? Now, without taking a bunch of time, this does factor. You could do it a couple different ways if you wanted to, but I'm just going to do like a guess and check method. You could do that thing, remember that thing where you said 6 times -1 is -6, and then you turned it into the grouping, Okay? You could do it that way and it would work, but you might get lucky and just guess correctly. So this is 3x and 2x, right? And what's going to give you a 1? A positive 1 and a negative 1, correct? So let's try that. Let's see if it works. All right? Now I know it works because I already did it, but let's just see if it does. 3x times 2x is 6x squared. That works. Outside is negative 3x. Inside is plus 2x. Negative 3x plus 2x is negative 1x. It works. And positive 1 times negative 1 is negative 1. That works. Would you agree that that is factored correctly? Yeah. You may not have picked those numbers at first. You might have had to try, right, and do a few of them before it worked out, but you should be able to get that. All right. So remember, we're trying to determine the rational roots. We're trying to find the answer. We're trying to find what x is equal to. So when they say find the roots, find the zeros, that means what? Or the rational roots. It means solve for x. Find what x is equal to. That's just a way that they use to say solve for x. I don't know, can you do this in your head? X plus 2 equals 0, right? We said x plus 2 equal to 0, so what's x equal to? Negative 2. Set 3x plus 1 equal to 0. You got to do a couple steps. Subtract a 1, divide by 3, so x is equal to what? Negative 1/3, because you subtracted a 1. What do we do here? Add a 1, divide by 2, so x is positive 1/2. There's your rational roots. Are they all rational numbers? Yes, they are. Rational numbers means you could make them into a fraction. Yeah, those two are fractions. You could make that into a fraction. So they're all rational numbers, and that's your answer. That's what they want you to do. So if you had this thing right here, I could take those numbers. I'm not going to. I could take those numbers and plug them in for x, and this thing will equal 0. Okay? Did you notice that all your answers are up in that list right here? Do you see it? Look, x is negative 2. There's the negative 2. X is negative 3, or 1/3. There's your negative 1/3. X is positive 1/2. There's your positive 1/2. You could, if you wanted to. Look, instead of doing it this way, you could have taken every one of those, right, plugged them into the original equation, and then see which ones equal 0, and then you could find your roots that way. I think that would be a pain, don't you? Maybe. I don't know, but I still think it'd be a pain, especially with the fractions. I think this way's a lot better. You had to try a few things here, all right, that's true, but I think this is a way better way to do it, all right, and that's why they came up with this, all right? Never enough time. I'll just do this one more example. We won't have time to do it anymore, but I'll probably have to teach the rest of it tomorrow. What did I say we're going to do tomorrow? Just working on stuff in class. So that's perfect. That gives me time to teach some of the new stuff tomorrow anyway. So I think if you can do these two, you should be able to do the homework for tonight. Almost positive. All right? It says find the roots. Again, what does it mean when they say find the roots? What does that mean? It used to mean nothing to us. Like, I have no idea what you're talking about. When it says find the roots, what are we doing? Just solving for x. That's all you're doing. All right, so find the roots of, and here we go. I'll just write it right here. So it's x cubed plus 8x squared plus 16x plus 5 equals 0. So I'm trying to solve for x. Now this one's actually, I think, well, at the beginning anyway, a little easier than the first one. Why? Because look at the lead coefficient. It's just a 1, isn't it? So really the cube, do I have to divide by anything? No, so I just kind of do it the way I've always done it, right? Or at least in the last lesson that I've always done it. So what are your factors of 5? Plus or minus 1 and plus or minus 5, right? So that's what I'm going to try. So which one am I going to try? Yeah, try 1. So f of 1, let's do it. 1 cubed is 1. That's 1 plus 8 plus what? 16. By the way, is there any way, look, these are all positives. Is there any way in the world that's going to come out to be a 0 anyway when I add all these numbers and they're all positives? No. So I could have stopped even before I started plugging those numbers in and said there's no way that's going to be 0. Would you agree? So be smart about it. What about f of negative 1? Well, there is a chance, right? If I get some negatives in here, yeah, I could get a 0 out of this. Let's try it. Put a negative 1 in for that. That's negative 1. Put a negative 1 in for that. That's positive 1 times 8, which is plus 8. Put a negative 1, that's negative 16, plus 5. Let's see what we get. What's that? 7. And that doesn't work either, does it? Nope, so that's not going to give you... So I don't even have to go all the way to the end. You follow me? Just get to a point where you know it's not going to be 0 and then move on. So now what am I going to try? Try 5, all right? I'll tell you right now, it's not going to work because it's all positives, right? So right off the bat, I know that's not going to be a 0. So my only other choice, which is my last choice, unfortunately, but my only other choice is to try f of negative 5. Now, I'll put some numbers down here because we're running out of time. So let me see where my thing is. So if you put a negative 5 in there, you get negative 125 because it's negative 5 cubed. All right, and then you put a negative 5 in for the other x. That's 200 plus 200. Then the next one is minus 80, and then plus 5. That does come out, oops, got to put 0 first. That does come out to 0, all right? Yay, it comes out to 0. So what do we do now? Now that we know that negative 5, now what's our factor? What's one of our factors by knowing that? X plus 5 is one of our factors, okay? So now what do? We take that f of negative 5, or that negative 5, put it right here, and just divide that into this. So you write the coefficients, 1, 8, 16, 5 in our synthetic division. This is the easy part now, isn't it? Multiply, negative 5, add 3. Multiply, negative 15, add them up, it's 1. Multiply, negative 5, it's a 0. Like I said twice already today, that has to be a 0. So what's my... what do I got? I got x plus 5 times, what's this going to be? 1x squared plus 3x plus 1. That equals 0. We good? So you set x plus 5 equal to 0, so x is equal to negative 5. We already knew that, so x equals negative 5. What about this, though? This is where it gets a little tricky. That's why this is the second example, not the first example. This does not factor, does it? But I do have x squared plus 3x plus 1 equals 0. How could I solve for x? Nope. Look, it's a trinomial. I can't factor it. What's my go-to choice that I could use every single time? Quadratic formula. Yes, the quadratic formula. So what is that? It's negative b, right? What's negative b? Negative 3 plus or minus square root. B squared, what's that? 3 squared, which is 9, minus 4. I've done this before, right? Got a lot of confused looks on your faces, I don't know. So minus 4 times a, which is 1, times c, which is also 1, over what? 2 times a, which is just 2. All right, let's simplify this. It's negative 3 plus or minus square root. That's a 9 minus 4, which is a 5, over 2. And that's basically what your x is. So I've got the first x is what? Negative 5. You with me? What's the other x's? You could separate them, or you could keep it like this. Let's separate them, all right? So x is negative 5. X is also negative 3 plus square root of 5 over 2. And x is also negative 3 minus square root of 5 over 2. So those are all my x's. Those are my roots, okay? And there you go. Now this one doesn't say find the rational roots, because with this, is this rational? No, it's irrational. When I take the square root of something that doesn't come out even, it's considered to be an irrational number. But this problem doesn't say find all the rational roots. It just says find the what? Find the roots, okay? And these are all the roots, all right? So if I took all three of those, right, I plugged it in for x, every one of these would come out to 0. Okay? All right. So, I didn't write it down here. Where is it? 10 to 15, I think. So it's 10 to 15, section 4.4. And this is, we'll call part A because we'll do part B tomorrow. Now, you got to remind me, tomorrow I do have to go because to be able to do tomorrow's lesson, you're going to have to know a couple other things. It's kind of similar to what we've been doing, but there's a little bit of difference in there. But you should be able to do this, okay? 10 to 15, and that will be due tomorrow.